everyone, good afternoon. My name is Dane Albinger, and I'm the Director of Vendor Performance at Alps Controls. Hey, we're so excited to have you guys here today as we have ONICON presenting on the FT-3500 mag meters that we're going to be going through in just a minute. Really excited to have you here to walk you through that new technology. This is going to be an interactive session overall, so please be aware of that. If you actually look to the right of your screen, there's a Q&A interface that you can use. So as throughout the session, if you have any questions or things that come up, we're going to be addressing all those at the very end. So just follow the instructions on the screen, and you should be good to go. But without further ado, I just want to introduce the ONICON team and get things kicked off. Guys?
Thank you, Dane. And want to start off saying thank you to Alps Controls for setting this up. And thank you for everyone attending. So again, today we're here to talk about ONICON's next generation FT-3500 insertion mag. So I'd like to start off with just kind of setting a foundation for ONICON. So we're a U.S. company based in Florida, and we've been around since the 1980s. And we really take an engineered approach. We have a lot of different technologies. So our viewpoint is we're going to use the right technology for the right application. We build and calibrate everything to the specific application it's going to be living in, and we factory configure it. So we tell all of our installing contractors the 10-minute rule. If you can't get it working in the first 10 minutes, stop what you're doing and call ONICON, because it should be plug and play. And then probably what we're most known for is our customer support. You have this customer support team through Alps. We also have a full engineering team at ONICON answering phones for support. And we also have an independent rep network that's going to be local to your territory. And, so since we're choosing the right technology, calibrating everything to the specific application, factory configuring it so it should be ready to go out of the box, we're able to back up everything with a 3-year warranty, including a 1-year no-fault warranty. So anything happens in that first year, someone jams it in a ball valve, hooks up the wrong power, you typically have one person installing it, one person wiring up, and one person communicating it to it. We're trying to protect everybody. So anything that happens in that first year, we'll get it back and replace it or repair it at no cost. So that's the ONICON 1-year no-fault warranty. All right, but today we're here to talk about the insertion mag, the FT-3500. But a quick look at the overall family. So we have 3 different models or types of electromagnetic flow meters. When most people think of mag meters, they think of the inline version, which you can see there, the FT-3200. That's where you're actually flanging it into the piping system. We also have the FT-3400, the blind version or no displayed version of our insertion mag. But again, today we'll be talking about the FT-3500. All right, so why do we like insertion mag meters so much? Well, first off, there's no moving parts. So if you think back and when ONICON started back in the 80s, we only had the turbine flow meter and worked great for clean closed loop applications. But what if the water quality wasn't as ideally as clean, for a cooling tower application, for example? And that's when about 20 years ago, we designed the insertion mag meter. So no moving parts, less wear and tear over time. It's also one-piece design. You can hot tap it into a live and pressurized system, which means it's really good for new construction, but also retrofit applications. Also, in insertion style meters, it doesn't matter what the pipe size is. So it doesn't matter if it's a 2-inch pipe or a 36-inch pipe, you're getting that mag meter technology at the right price. So overall, this is really the best solution for open loop systems. So how does the insertion mag meters work? Well, if you remember physics class back in the day with Faraday's law says if you create a magnetic field and put a conductor through that magnetic field, in this case, it's water, it's going to induce a voltage. So what we're doing is we're measuring that induced voltage, and that's going to be proportional to the velocity going through the pipe. All right, so what applications is this good for? Well, I talked about how we originally designed this for cooling towers, but also we're really seeing a shift in the industry going to no moving parts. Frankly, chilled water, hot water systems, that water quality isn't as clean as we'd like it to be in a lot of cases. And our end users just don't have the technicians and support teams they used to have. So we've really seen a shift where people are using mag meter technology for all applications. It's also great for domestic water applications. It's NSF rated. Really any water or glycol application with at least 20 micro Siemens of conductivity. All right, so why are we using flow meters? I think a lot of different reasons of what people are doing with flow measurement, but I really kind of break it down into three different applications: monitoring, controlling, and billing. It's nice that from a monitoring standpoint, having continuous monitoring points throughout your system to really understand where the flow and the energy measurement is going. Also control. When do I want to turn on that second chiller? When do I want to turn on that third chiller? Or when do I just want to make sure I'm maintaining a specific flow rate into a chiller? So using this measurement for your control strategies. And then lastly, billing. It's not quite fair to bill off of square footage. You're seeing more and more tenants starting to bill off of BTUs. And then the last one here, those are my three main points. The last one that I've really seen more recently is sustainability, or having our end users wanting to measure their ESG initiatives, where typically you're only get one bill from the utility of how much water consumption or gas consumption. Well, if you have more flow measurement throughout your system, you can understand where the water is being consumed and start meeting those conservation goals. All right, now to dive into the FT-3500. So this is suitable from 1¼ inch to 72-inch. There is two different sensor types. We do have one for the smaller pipe sensors. We also, for accuracy, it's a 1% of reading device. We'll dive into the accuracy here on the next slide. The enclosure, NEMA 4, so you can actually put the transmitter outdoors if needed. And then the actual sensing element is a NEMA 6, which if you could be submerged if necessary. And then lastly, output signals. You have the two analogs. You got temperature inputs, pulse and inputs and outputs, or standard frequency output, and then network communication that we'll talk about in here in a little bit. All right, so I'd like to take a few minutes to talk about accuracy. And so this is one of the most important slides in here because it demonstrates the difference between a 1% of reading device versus a 1% of full scale device. And I talk to engineers all the time, 1%, they must be the same. What's the difference? And so that red line on the graph is a 1% of full scale device. The blue line is the accuracy of our FT-3500. So both meters at 30 feet per second can read our 1%. But when you start looking at the applications these meters are living in, so that blue shaded region is typical chilled water, hot water, condenser water applications at 4 to 8 feet per second. So as you can see at 4 feet per second, that 1% of full scale device is plus or minus 8%. And then when you talk about domestic water or makeup water applications, now you're dealing with velocities down to like 1 feet per second. Well, that 1% of full scale device is plus or minus 30%. While we're maintaining a 1% over that very wide range and then 2% at the low end. So to kind of hit this and do an example to hit this idea home, you have two flow meters that both could read 0 to 5,000, but you're trying to measure 300. Well, a 1% of full scale device is going to be 1% of 5,000 or plus or minus 50. All of ONICON's flow meters is a percentage of reading device, or 1% of the 300 or plus or minus 3. Initial look, both 1%, but they mean something much different. So where does this accuracy and performance coming from our flow meters? So it's because we wet calibrate every single one. So, we do ask a bunch of questions up front. What's the application? What's the pipe size? What's the pipe material? What's the flow rate? But the reason for that is you tell me it's a 6-inch pipe, chilled water, variable flow, but the average flow is 500 GPM. Well, we'll build the flow meter, physically put it into a 6-inch pipe and put 2,000 gallons through it. So every one is going to come with a wet NIST traceable calibration certificate for the application it's going to be living in. And then again, it's factory configured, so it should be ready to go out of the box. And now I'll pass it over to Brian Woodruff, one of our regional sales managers.
Yeah, thank you, Mike. I appreciate it. So we're going to dive into the communications. So in additional to the traditional method of an analog, this was actually designed for networking. It's great because you have the option of doing RS-45 and or IP, whether that's BACnet or Modbus. You can also set up some of those object points to do some of your alarms at the upper and lower limits. At the bottom there, you're going to see some of the data and available object points that you have available. What's great about this is you won't need any GUI software or laptop to do any changes. It's all field configurable. So you're able to go in and, for IP example, you're able to change the IP address, the subnet mask and gateway, all through the actual remote transmitter that accompanies the meter. The touchscreen display. So we're really excited about this. It's basically like your cell phone. So you're able to go through all the changes, configuration, changes that you're able to see. So here, if you see on the right-hand side, you have flow rate and energy rate for the BTU version. Or if you want to change that to where you want to see totalization over a month period, daily period, as well as the temperatures of supply and return, you have that functionality. So it's all user configurable to what you want to see on those screens. So we're really excited about that as well. Next, meter info. This is really important. So if you ever call ONICON, one of the first questions you're going to be asked is the serial number. Well, a lot of times that hanging ID tag that we have that accompanies the meters can be lost. They can be cut off, like it's not needed. Or imagine the meter is 30, 40 feet in the air and you're not able to see that information. So having that remote display at eye level, you can quickly go through the touchscreen display and see all of the meter info data. And that's to see, the serial number, calibration information, and then knowing, as Mike mentioned, that 3-year warranty or that 1-year no fault, you can quickly go back to the display and see if you're still within that time frame. Plus, you're able to check any type of configuration of the inputs and outputs available for that flow meter. Talking about configurable, we have the changes of the pipe. So for example, if you're in the field and you happen to order the flow meter for a 4-inch carbon steel pipe, schedule 40, and then you get out in the field and you see that it's a 6-inch, thankfully you won't have to contact ONICON. With the previous model, you had to actually fill out a form. You'd actually get an S19 file, take 3 to 4 days to get that file. Then you'd have to get a laptop, be accessible to the flow meter, download the information in the flow meter to make those changes. Thankfully, with the touchscreen display, you're able to quickly make those changes that doesn't affect calibration, which is great. So another great feature, like I said, we listen to our customers. We like to hear, the issues they have in the field, especially for those contractors or, the utility managers that are there using these meters. Also, we have the alerts and meter diagnostics, which is great because you're able to see all the errors, alarms, and warnings that might be eliminating your flow meter from operating as advertised. So again, as I mentioned, if you call tech support previously, you would just have an alarm state. So it triggers, at your BAS and you're like, my flow meter's not operating. What can I do? Well, for the tech support standpoint, you're having to troubleshoot, is this the B2 side of things? Is this the flow meter? Is it inserted in the pipe? So thankfully, you're able to go to these warnings or alarms to tell you, and sometimes if it's just a warning, it's just able to still read flow, but there's something you need to look at in your system. Alarms or errors, then you really need to dive into. It could be as simple as a temperature sensor not touching the application and getting an accurate reading to maintain, say, a chill water at 10-degree delta T and so forth. As well as, if you notice there on the right, the waveform. So that's awesome because you're able to see electrode 1 versus electrode 2 and able to see when the signal's coming in, when it's going out, and if both of them are reading or if one of them is not. So we're really able to dive in without having you send the meter back for repair every single time. Then you're out roughly 2 weeks. We're able to handle a lot of this on site with someone just in front of that display. Next, I'll turn it back over to Mike to talk about the BTU options.
All right, so this new FT-3500 can be more than just a flow meter. It can actually do a BTU meter. So historically, any of our flow meters could be tied to a BTU system like our System 10. Now this can all happen inside the FT-3500. I'd like to start off talking about BTU measurement as a whole. So when you think about when ONICON started back in the 80s, we only sold flow meters. And so what happened was we'd get a phone call 3 years later and they said, hey, your flow meter is not working right. We're like, hey, we built, calibrated, and figured it for your specific application. Why don't you think it's correct? And they said, our BTUs aren't adding up. And so that's when ONICON started diving in to understand where these inaccuracies are coming from. Because typically they would just take a calibrated flow meter to our TDs and go back to the building automation system. So what ONICON did is that we identified all these different sources of error for that BTU calculation. And while this all comes into play, what we found that most of the time, the inaccuracies was coming from the temperature sensors. And the reason for that is, RTDs, there's different qualities and grades out there, but easily could be a quarter degree off, a half a degree off, a full degree off. Well, even if it's a half a degree off on the supply and it's a half a degree off on the return, when you look at that delta T, that's potentially 1 degree off. So 1 degree off in a 10-degree chilled water system, you're looking at 10% error before you even start considering the other sources of error. So what ONICON does is we provide calibrated and matched temperature sensors. So the key word there is matched. You tell me you have a chilled water system with BTU measurement. Well, we take the 2 temperature sensors, we put them in the same bath against a NIST traceable master sensor. So each one will have its own slope and offset that we're programming into our BTU system. So now, even if it's a quarter degree off on the supply, it's a quarter degree off in the return in the same direction, which offers a really high-end BTU accuracy. All right, so now you have the calibrated flow meter, calibrated temperature sensors going back to the BTU system. As you can see there, the flow and BTUs. And, this is great because before, when BTUs weren't adding up, who do you blame? The flow meter, the temperature sensor, the person calculating BTUs. ONICON is now providing a complete calibrated system for the flow meter, temperature sensors, and BTU system. And back to you, Brian.
All right, so we're just going to touch on the installation procedures real quick on this flow meter. I'd like to revert you to visiting our website and or our YouTube channel, and you'll see all of the installation procedures to hopefully achieve a smooth installation. So also when you order your flow meter, just go ahead and order the kits through ONICON. We have the standard kit available for dry tap, and then we have a hot tap kit available as well. And why that's important is because the insertion depth that we discuss in the insertion flow meter, you've got to get at that right area in the pipe for the best measurement. Things to keep in mind for non-conductive pipe that we have seen more prevalent this day is going to be, that PVC, Aquatherm, HDPE. Well, the thing about this technology and considering the electromagnetic is you're going to have grounding rings and or grounding probes installed in that pipe. So new construction, it's great because you have to actually flange in the grounding ring. But if it's going to be a retrofit, you can do our grounding probes. So we like to talk about the straight run, mainly so that we can achieve those accuracies, especially in those applications where we're billing on thousands of dollars on these flow meters. So we have to achieve the best straight run. So in an ideal world for a manufacturer, we dream of this on the right, but obviously we know we're dealt typically with a mechanical room that looks like that on the left. So if you are having difficulties finding that straight run, definitely reach out to ONICON and we can help assist looking at maybe the supply versus the return and so forth on a closed loop system. So rule of thumb, and basically what you hear in the industry is 10 pipe diameters upstream, 5 downstream. So what that doesn't take into account is actually what that upstream or downstream obstruction is. Mainly the upstream is what we want to look at. So you see here the velocity profile. So this is just an example of a 90-degree bend and seeing some of the swirls and the turbulence that takes place after that straight run. So this is the basic example. And if you have that 10 pipe diameters, you see how the velocity profile is a lot more even. Then we're able to insert that meter in the pipe at an even average velocity profile there. So next, just a few quick slides on CFD modeling just to show you some of that swirl and turbulence that happens through the pipe. This is a good model here, just showing some of that swirl from, this is actually multiple bends out of plane at a different angle. So just rotated there to show that. All right, so talking about straight pipe run requirements. So definitely things that we try to avoid are modulating valves, inflowing tees, multiple bends out of plane, because then it greatly increases that amount of straight run from that obstruction. It can be upwards of 30 or 40 pipe diameters. Things that are workable are outflowing tees, pipe reductions, and so forth. And then obviously it's ideal to have the longest amount of straight run. So an example is we were on a building one time and they had roughly, say it's a 10-inch pipe, they had 100 feet of straight run. Well, the mechanical just went 10 pipe diameters, installed the meter, and then they had 90 pipe diameters downstream of the flow meter. So in that case, we definitely always recommend, like say the 80% upstream, 20% downstream rule. You want to give yourself the longest amount of straight run possible from that obstruction to your flow meter to get the most accurate measurement. Back to Mike to wrap up for us.
Thanks, Brian. And yeah, just kind of recap here. So that's the FT-3500. And, as you can see, we have a lot of different technologies that we showed early on. This is just one tool in our tool bag. We really like to take an engineered approach. Let's use the right technology for the right application. You saw the pictures of our calibration loop. We calibrate everything to the specific application it's going to be living in. So everything comes with a calibration certificate for your specific application. And since it's factory configured, again, the 10-minute rule, if you can't get it working in the first 10 minutes, stop what you're doing and give us a call. And then, our customer support, you have the Alps support, you have our engineering team at ONICON, and then you have our local rep support as well. So because we're doing what we feel like we're doing all the right things here, again, the 3-year manufacturing warranty and what ONICON's, famous for, the 1-year no fault. So anything that happens in that first year, we'll get it back and repair it or replace it at no cost. All right. And thanks again for everybody for attending. I think we're going to hold tight and answer some questions here.
Okay, terrific. Thanks everybody for attending. I got a really good turnout here, so we're excited to be speaking with you all today. And we do have a bunch of questions here in the queue ready to go. So let me get to them. We've got one person who wants to know, let's see, if I have ultra pure water, which has low conductivity, what meter should I use?
Yeah, that's a great question. So again, the insertion mag meter can measure down to 20 microsiemens. So if you had ultra pure water, we do have different technologies for that. The ultrasonic technology is a good choice. That could be the wetted ultrasonic for smaller pipes, or the clamp-on ultrasonic for any pipe size. The vortex technology has limited turn down, but is a solution there. And actually, if it's just low conductivity, maybe in the 5 to 20 microsiemens, probably too low for the insertion mag, but still could be used for our inline mag technology or our insertion turbine flow meter.
We have a question from Philip Braga, who wants to know, is there a prefab cable from the sensor to the display?
Yeah, Brian, I'll let you handle that. It is a prefab cable.
Yeah, it is a prefab cable. So it comes standard with 25 feet, and you're able to order up to 200 feet of remote cable. So in those instances where they're installed fairly high in the air, 50 feet or so, you can still get that transmitter at eye level display. Good question.
Our next question is anonymous, and they want to know, has this been recorded so we can share it with others? And I'm going to go ahead and answer that and say, yes, we're recording right now, and we will be putting it onto the Alps Controls YouTube channel within the next couple of days. So you can share it and watch all of these questions all over again. Thank you. Let's see. We've got another question from Daniel Vincent. He wants to know, field service reading sensor?
Might need a little bit more context there. Field service reading sensor. So I'm not exactly sure what he means. Maybe in regards to commissioning and service. So if he wants to provide more context, they're happy to answer it, but I can kind of give you 2 different instances. So from a commissioning and standpoint, you install the flow meter. There's a commissioning guide in the back of our manuals that kind of goes through that process to confirm that you've installed it correctly. Then there's a display that has those alerts that Brian was talking about to kind of help you confirm, like, hey, the temperature sensor is an open loop. That might mean you have to actually land the wire to the temperature sensor. So those diagnostics will help you commission the meter as well. And then, so that's really on the startup process. In regards to like, years down the road, and you want to recommission the meter, well, you have that display always that gives you those alarms and so forth. You also can get a lot of that information over the network, so BACnet or Modbus. And to kind of take this conversation a little bit further, I get this question a lot. It's how often do I have to recalibrate a flow meter? And the answer for me is typically it depends. It depends on what you're doing with the flow meter. And I can kind of give you a few examples. So, we have some customers that are billing tens of thousands of dollars off of our meters every month. So we've seen some customers recalibrate our meters every 6 months, every year. However, on the other side, we've seen flow meters come back after 20 years. Like, wow, this meter hasn't been back in 20 years, and it's still within a couple percent of how we originally shipped it. So for something to, and then I like to differentiate the terminology of validation versus calibration. So for something to be recalibrated, it needs to be compared to a standard that's like 4 to 10 times as accurate. So it's really challenging to recalibrate a flow meter in the field. That's typically when, that's why I love those insertion meters, because you can pull it out of the ball valve, shut the ball valve, remove it without shutting down the system. Only a few $100s to get the meters recalibrated, get it back in your hands in a week or so. Versus validation, that's where you're just comparing the flow meter or validating the flow meter is still within calibration. So that's something that you can do in the field. And, a few different ways to do that. We have clamp on portable meters that you can clamp on the outside of the pipe downstream of the flow meter or upstream to find a good location and validate, hey, that's still within a couple percent. I can validate that flow meter still within calibration. You could use a secondary insertion meter. So a few different ways to handle that. And if you really want to understand, come up with a really in-depth plan on how to manage your building, that's something that, encourage you to reach out to ONICON. Let's understand what your needs are, what your system looks like, and we can come up with a plan with you.
Cal Clendenin wants to know, can the BACnet IP be in daisy chain configuration?
It cannot, unless I'm misspeaking, Brian. From my understanding, the MSTP can be daisy chained, but the IP, there's no IP input into the card.
I think what I understand is there's a foreign server registration that allows a unit to be remotely routed to another BACnet network over IP, relieving the need for the customer to install multiple BACnet clients or routers. But that's what I'm aware of now.
Yeah, and that's a good question. I'll circle back around. And if that's a need that's in the industry today that we don't have, that would be good to know so we can implement it.
Matt Scoville would like to know, are there 2 RJ45 ports to allow daisy chaining IP devices, or does each meter need to home run to a network switch?
Yeah, that's kind of the same question as before. So I will get full clarification on how that works for us and get back to both of you.
Harry Eargang wants to know, does the BTU version allow you to eliminate the need for using SYS20 or SYS10?
It does. So the FT-3500, you do need to order it that way, but you can order it as a BTU version, and that FT-3500 display will act as the System 10 or the System 20. There may be, it will certainly have all the features that the System 20 has. And frankly, in today's world, the same as the System 10, besides maybe the 4 analog output card. The System 10 has a 4 analog output card that you can get outputs for both flow, both temperatures and energy. So this would only have a dual analog output, not a 4-channel. But besides that, it's going to resolve 99% of those BTU applications where you don't need a peripheral device.
Paulo Sanchez is asking, is there a bi-directional magnetic meter available?
Yeah, so this one inherently does come bidirectional. There's a pulse output to show you open is one direction, close is another direction. And then, of course, we'll display all that information on the display and communicate both directions, over the network.
Martin Altschul is asking, what are the advantages and disadvantages compared to a System 10?
Yeah, I kind of answered that, but I'll reinforce it. It really does handle 99% of the features of the System 10. Besides that 4-channel analog output card, and really there's more pulse puts into the system or the FT-3500, so it gives you more advantages where if you had a local domestic water meter, you could actually use a pulse input into the FT-3500 as well. However, the exception would be we do have a brand new System 1000, which can do multiple channels. You can do like a BTU, a chilled water for BTU and condenser water BTU, and hook up 4 additional analog inputs. You can do like chiller efficiency, boiler efficiency in that new System 1000. So I would say that System 1000 has a lot more features, additional inputs, and efficiency calculations that the FT-35 wouldn't have. The FT-3500 would only really handle one application.
Yeah, and I'll touch on that a little bit as well. So if you think about the System 10, depending on, if you had all the bells and whistles, you could actually do a dual net. You can do an additional, say, domestic water meter for totalization. Plus, if you're not using the functionality of the temperature sensors, you can actually bring in additional flow meters. So it depends on how you're using the System 10. So some of that functionality wouldn't be available in the FT-3500. But definitely, as Mike mentioned, we do have the System 1000 available.
Russell Harris asks, what is the current lead time for this meter and the BTU meter?
That's a good question. I think 3 to 4 weeks typically is our current lead time. And, I think ONICON's always tried to target 2 weeks. But I think right now we're 3 to 4.
Okay, George Huber is asking, what is the conductivity range for the meter to operate properly?
Yeah, good question. It's above 20 microsiemens, and I don't think there's really a limitation on the high end. So it would just be on the low end, 20 microsiemens. And kind of touched, I think someone kind of asked that, what do I use for non-applications under 20 microsiemens? The inline mags and insertion turbines can read down to 5. And then the ultrasonic and vortex technology can read down to 0.
We have a question about, are there any options for integration to cloud-based systems?
That's a good question. And currently, no. ONICON does have a sister company that does, that can handle that. So it would be an additional device. It wouldn't be built into our system. But if you have a specific need, we can engineer that and find a solution for you.
Sandra Ordonez would like to know, does the piping need to be completely filled? What happens when there are bubbles?
Yeah, I'll take that one, Mike. Yeah, it definitely needs to be all the way full and no air bubbles. So what ends up happening is because it creates that electromagnetic field, those electrodes sensing are on that sensing element. So if any air, it actually interrupts that signal. So you will quickly, if you ever see one that's reading and then it drops out and it'll go into alarm and then it starts reading again, typically that means you have air in the system. We just ask to, install a purge valve, a pressure relief, and so forth to definitely have a full system.
Yeah, just to thank you, Brian. To kind of add to that, I think it will come into an alarm of an empty pipe alarm. It does need to be a full and pressurized pipe. But when most people ask about bubbles, they're talking about micro bubbles, and they probably have experienced issues with micro bubbles in the past. And I would say like a clamp-on ultrasonic or an ultrasonic technology would be more susceptible to micro bubbles. I really feel like the insertion mag meter and mag meters are pretty robust to micro bubbles, as long as the pipe is full and pressurized.
Ahmed Handy wants to know, I have a BTU meter that is running normally, but showing test mode. I tried replacing the card, but still nothing changed. How can I resolve this issue?
Let's have our tech support handle that one. That sounds, I'm not sure what would put it into a test mode. So actually I might know the answer to this. So in the FT-3500, you can simulate flow to kind of, sometimes people want to commission the meter before there's flow in the pipe. So you can actually simulate flow through the front display. I do that with our live demos sometimes. So there is a feature in there to simulate flow that would put it in test mode. So my first recommendation would be go into that feature, make sure that feature is disabled. If it's still in test mode and that feature is disabled, then call our tech support team and let's figure it out. And that is the main phone number, 727-447-6140.
Alec Tamrazian, sorry if I slaughtered that, Alec. He wants to know, is it possible to replace the FT-3500 for existing ONICON turbine flow meters?
It is. Yeah, they're both installed through a 1-inch ball valve assembly. And it does require a little bit more power. So you're going to want to look at your power source going to the turbine meter. But it's involved in this, it's installed through the same ball valve assembly. And if you just have the serial number of your turbine meter, we can go ahead and build and calibrate that FT-3500 to the same parameters as that turbine meter.
Can you provide a brief explanation of how hot tapped installs are accomplished?
Yeah, that's another good question. And so say that you have a pipe and there's already flow going through the pipe and it's a retrofit application and you decide you want to install BTU measurement. So what happens is we'll ship typically and oftentimes the installation hardware in advance. So we do, I think Brian touched it based on this briefly, but there's a standard kit, which is a 1-inch ball valve assembly, and then a hot tap kit, which is a 1.25-inch ball valve assembly with a 1.25 to 1-inch reducer. So what happens is the mechanical will use what's called a hot tap drill, install the drill through the ball valve assembly and actually drill the hole under pressure. And then once the hole's drilled, it catches what's called the coupon. They retract it from the ball valve and shut the ball valve. So they can actually drill that hole with like a hole saw while there's a live and pressurized system. Meanwhile, we're bringing out flow meter that can be installed through the ball valve assembly. I'm a good learner with visualization. Recommend just going to YouTube. YouTube has some great videos that kind of demonstrate how hot tap drilling is worked.
Let's see. We have one question wants to know, what is the main difference between the 3500 and 3400 series?
Another good question. FT-3400 is our blind version. So if you're familiar with our F-3500, that has been discontinued. And so what we've done is we've come out with the next generation insertion mags. It's the FT-3400, FT-3500. The FT-3400 has no display. There is more features than the original F-3500. You can hook up to a laptop. It's got a GUI interface. You can change the parameters in the field, but it's standard, just analog frequency and pulse outputs with no display. Where the FT-3500 is where you get the display, you get there's the BTU option if ordered that way. You got the network communication with BACnet and Modbus, RS-45 and IP. And then, probably most importantly, all those diagnostic features right there on the screen.
Lee Sabian wants to know, in the IP version, is the MAC address of the NIC printed on a sticker on the outside of the unit? Or is this information only available from the display of the unit after it is powered up? The reason for the question is that the customer assigns the IP address by MAC.
That's a good question. Brian, you know the answer to that one?
I don't, because I know through the network settings, I'm not sure if that's accompanied with the shipping material. We need to look into that one.
I know our System 10 there's a sticker for it. So yeah. I would assume that it's the same for the FT-3500. That's another good question that I'll circle back around and confirm.
All right, we have one person wondering if, and maybe more than one person's wondering, but one person asked if there are any tariff implications of this product.
Yeah, it is a US made product. So it's not going to be any great impacts, like if it was manufactured in Mexico or outside of the US. I think, we're going through that process now in full transparency where, you know, what parts of our materials are coming from. A lot of our suppliers are also in the US, but it's not just those direct suppliers. Well, where does our suppliers get their material? So there might be a ripple effect. So there might be some minor implications here, but I would say it's a minimum compared to what I think a lot of other people are seeing. Therefore, because it is a US made product.
Matt Scoville is back with another question. He wants to know, what are the options for providing power to the FT-3500? Can it be powered by 24 VAC?
I can answer that one. Yes, it can. You can do the 24, and then I'll actually pull it up right now on which options you have for that. So you have you can do VDC or VAC for input power. So it's 22 to 26 VDC and 20 to 28 VAC.
Philip Braga is asking, I believe you said there were 2 analog outputs on the meter. What information is sent out of these outputs?
So you can actually set those analog outputs, whether you want a 4 to 20, 0 to 10, or 0 to 5, and that data, depending on if you have a BTU meter or not. So for example, if it's just flow only, you can get flow rate. Flow total can actually be over the pulse contact. And then if you have the BTU version, you can set it up for whether you want, flow rate, flow total, energy rate, energy total, temperatures, and so forth. So it is configurable as well in the field.
It's configured and offers redundancy.
Exactly. Yeah.
Ben Callender asks, I have a few FT-3500 meters to install on a job right now that came with RTDs that I haven't seen before. How are they installed in the pipe? We have usually seen thermistors that thread into a thermowell.
Yeah, so they can be ordered 2 different ways. Still more commonly, they are. So we offer our standard ONICON solid state temperature sensors, which you're probably used to. And then there's another option for RTDs. So my guess is it was whatever the order processing was on, whatever model number was chosen, it asked for the RTDs when ordered. Those are still installed through thermowells. They might look a little bit different than our standard temperature sensors would. And the reason that we're seeing sometimes more specifications that say that they require specific kind of RTDs. So that's why that's an option that you're probably not used to with ONICON. But since you have a specific project that you're looking at, if you could provide your original sales order number, we can look up exactly what temperature sensor set we sent with, and can provide specific details with installation guidelines for that specific assembly.
Colleen Egan is asking, can the meters be powered over Ethernet?
PoE. That's another good question, and currently not. ONICON is just starting to implement PoE. I know we've implemented it on our steam meter, and we're looking at implementing it on our ultrasonic. So I think eventually we will get there, and I'd love to learn more about how often you're seeing that need. Maybe we'll speed up that process. That's a good question.
Andrew Ames asks, can you reconfigure the pipe type and size via backnet connection or just through the remote monitor?
I believe it's just through the front monitor. Can you confirm that, Brian?
Yeah, it needs to be accomplished through the transmitter.
Yeah, and I'd like to maybe spend another minute on that question. That's a good question. If you do, everything's been calibrated for a particular pipe size. And what we've learned over time is if it's calibrated in a 4-inch or larger pipe, the pipe wall doesn't have as much of an effect on the calibration. So you can change it from an 8-inch to a 10-inch pipe, or a 6-inch copper to a 6-inch carbon steel. However, what we recommend is if you do change that field, we give you the option to print a new configuration tag. So make sure you're putting it with the configuration, like you can see it on the display, but whatever documentation you have about that meter, make sure that you've documented that you've made that configuration change. Now what happens if it's smaller than 4-inch? You know, if it's going from a 2.5-inch to a 3-inch, for example, that's where we still recommend to send it back to ONICON and get it recalibrated. We'll do that under the no-fault warranty. Frankly, will it still work? Yeah, it'd still work and probably be within a couple of percent, but you know, why not dial it in to that 1% accuracy that the meter can perform?
That brings up one other point I want to make. Mike mentioned it earlier. So if you're actually dealing with a 1.25-inch to 2.5-inch, it actually has a different sensing head. So that would be the point where you do not want to use that in anything larger, 3 inches and larger. You would actually need to change that out, as well as say you had a 6-inch and you're going to a 30-inch. At that point, that meter, because of the stem length, will not be able to get into that application. But as Mike mentioned, it's just small adjustments, right? If you're going from a 4 to 6, even 4 to 8, you should be fine. What happens is once you go in and change that configuration, it will actually provide a new depth gauge length. Then those have a set screw in that depth gauge, because you can quickly adjust it, just use a measuring tape, and then you can insert it at the correct depth because you did change that configuration.
We got a handful of questions still to go here, and then we can probably wrap it up. I understand there is a display, but in cases where the display is not on a convenient location, is there the capability to do Bluetooth connectivity to the meter?
Yeah, so in that case, I think we would recommend our FT-3400, the blind version. And we're implementing Bluetooth into that version. And right now, our Bluetooth capabilities is through a laptop software. It is an active project at ONICON to create it with an app. So I'd be saying in the near future, keep an eye out for, you know, the ONICON app with our Bluetooth capabilities. Probably worth mentioning, you have to order it with the Bluetooth capability. We do not provide Bluetooth with every meter because a lot of requirements, government requirements and so forth, data center requirements won't let you have Bluetooth in their devices. Good question, thanks.
Quinn Harris is asking, is there an online tech available for backnet troubleshooting? For example, I have worked with some meters and at times hardly anyone understands the backnet side of the device.
Yeah, that's a good question. I think in the back of our manual, we've been trying to be a little bit more diligent about troubleshooting backnet issues. But we have several people on our tech support team are more experienced with backnet and Modbus than others. So if you know, at a high level, if the manual's not giving you troubleshooting tips aren't helping, let's get you in touch with like maybe that one of the more experted backnet individuals at ONICON. So you know, you can call in, but sometimes an email, you know, to sales@onicon.com or tech support@onicon.com, same thing. And we could schedule a time to make sure that you get in touch with the right person at ONICON.
All right, we have someone who wants to know, what is the communications method for the built-in BTU meter? Backnet MSTP, Backnet IP, Modbus RTU?
Yeah, so it already inherently has a flow meter. The temperature sensors, our solid state temperature sensors uses a 4 to 20 back to the transmitter. And then the FT-3500 does have to be purchased with network communication, but you get all 4 of those are all on the same network stack. So you get BACnet MSTP, BACnet IP, Modbus RTU, RS-45, Modbus TCP and IP are all on the same network card when you buy the networked version of the meter.
George Huber wants to know, in regard to insertion depth, Does the FT-3500 meter still come with a steel rod for setting correct insertion depth?
Yeah, and that's what wanted to touch on. It's still a company on each one, but previously it was actually cut to length. So if you did do any of that configuration, you had to use a tape measure and so forth to figure out that depth. Now that steel rod that she's mentioning actually has a set screw in the side. So if you do any changes, it will give you that new gauge length. You can loosen, it's just got heat shrink over. You can loosen that set screw, change the length, set it back.
Yeah, that's a good question. It's the next generation depth gauge.
Yeah.
Daniel Vincent's asking, are you able to change the sensor in the field? Little props if they get damaged.
So unfortunately, there's actually calibration data held inside of the sensor, I guess, technology, if you will, and the transmitter. So we would recommend if something did happen, we would need both of them back and then calibrate them together as a pair.
Okay, Michael Overy is asking, metallic pipes don't require grounding rings, only plastic non-metallic, correct? Same thing with flanged flow meters.
What we've seen is that the pipe wall actually kind of acts as grounding. So you still need to ground the meter to an earth ground, but in regards to the actual grounding rings and grounding probes, it's pretty much required in non-metallic pipe. That being said, we have seen some engineering specifications out there that are probably, we'd say, maybe overly conservative and still specifying it on all pipe materials. But yeah, we're installing them all day, every day in metallic pipe with no grounding rings or no grounding probes with no issues.
Okay, here's a question more along the line of physics than the actual product. Somebody wants to know if the Faraday's law application here, is that the same thing that's used for vehicle detection systems at traffic lights?
I don't know how vehicle detection systems work. I would assume that's more of ultrasonic technology, but I don't know. So ultrasonic technology, there's two different ultrasonic technologies. That's where you're sending an ultrasonic wave. So ONICON uses a transit time where you're sending an ultrasonic wave this way and an ultrasonic wave this way. And the transit time difference is going to be proportional going to the velocity going through the system. There's another ultrasonic technology that you see in like municipal or dirtier applications, which is called Doppler, where it's just only one ultrasonic signal and it's ricocheting off of particles in the pipe. And so my guess is that vehicle detection system is using a Doppler ultrasonic wave, but I've never looked into that, so don't hold me to that. I doubt it's electromagnetic. I don't think they're creating magnetic fields at traffic lights, so I would say it's a different technology. Yeah, thank you, everybody.
Thanks, everyone.
Also, a quick parting reminder that we are still announcing the 3 winners of the Arctic coolers. If you win, you will be receiving a notification via email within the next week. So thank you all for attending. Appreciate it.